friends, welcome back to our channel Physics Tutorial. Today we are going to discuss the second chapter of plus 2 physics, that is electrostatic potential and capacitance. So in this chapter we will study all the important derivations, equations and concepts related to electrostatic potential and capacitance. So we can see what are the topics to be covered in this chapter. Here we are going to discuss electrostatic potential, potential due to a point charge, potential due to an electric dipole, potential due to a system of charges, equipotential surfaces, potential energy of a system of charges, potential energy in an external field, electrostatics of conductors, dielectrics and polarization, capacitors and capacitance, the parallel plate capacitor, effect of dielectric on capacitance, combination of capacitors and energy stored in a capacitor. In this chapter we will discuss 2 points, that is first point is electric potential and then capacitance. So we will have a detailed study about electric potential and then capacitors also we will discuss. And we can see that this is a continuation of first chapter, because in the first chapter we were dealing with the charges at rest. Clear? Here also we are studying about the charges at rest, that means electrostatics only we are going to study here. And the main difference is that there we were studying about electric charge intensity, that means the for understanding electric field we were dealing with electric field intensity at a point, right? So that was a vector quantity, but here we can see the electric potential is a scalar quantity. So that is the main difference between these two. And the dealing electric field was actually a little bit difficult, right? Because there were direction as well as magnitude. And in this case we can see that this will be more easy to study, because here only scalar quantities we are studying, right? That is electrostatic potential means that is a scalar quantity. അപ്പോൾ ഇവിടെ കുറച്ചുകൂടെ ഈസിയാണ് ഇലക്ട്രോസ്റ്റാറ്റിക് പൊട്ടൻഷ്യലിനെ കുറിച്ച് പഠിക്കാൻ, കാരണം ദിസ് ഈസ് എ സ്കാലാർ ക്വാണ്ടിറ്റി. ഓക്കെ, ഇനി എന്താണ് ഇലക്ട്രോസ്റ്റാറ്റിക് പൊട്ടൻഷ്യൽ എന്ന് നോക്കാം. സോ for understanding electrostatic potential we can consider a point charge. Here we have a charge plus q. Suppose this is the charge, and if we place a charge here, what will happen? There will be a field around this, right? And here we are placing a point. Here we consider a point P, and for finding the electrostatic potential or electric potential we have to bring a unit positive charge. Suppose in this side we have a unit positive charge, plus 1 coulomb charge, that is the unit positive charge that we are keeping here, and we have to bring this unit positive charge, this is at infinity, and we have to bring this unit positive charge from infinity to this point P. So this work done will be stored as the electric potential. Okay, so the electric potential at a point means it is the work done by an external force in bringing a unit positive charge from infinity to that point. So here we can see that the point will be here we have a positive charge, and the influence of this point that will affect in this point P. Okay, so ഈ പോയിന്റ്, അതായത് പോസിറ്റീവ് ചാർജ് കൊണ്ട് ഉണ്ടാവുന്ന ഫീൽഡ് എവിടെ ഉണ്ടാവും? ഈ പോയിന്റ് പിയിൽ ഉണ്ടാവും അല്ലേ? അതായത് ഈ ഫീൽഡിലാണ് എന്ത് വെച്ചിട്ടുള്ളത്? പോയിന്റ് പി വെച്ചിട്ടുള്ളത്. അപ്പോൾ അങ്ങനെ ആവുമ്പോൾ എന്ത് ചെയ്യണം? ഈ പോയിന്റിലേക്ക്, അതായത് പോയിന്റ് പിയിലേക്ക് ഒരു യൂണിറ്റ് പോസിറ്റീവ് ചാർജിനെ കൊണ്ടുവരണം എന്നുണ്ടെങ്കിൽ എന്ത് ചെയ്യണം? വി ഹാവ് ടു ഡു എ വർക്ക് അഗെയിൻസ്റ്റ് ദിസ്, അല്ലേ? ഇവിടെ ഒരു പോസിറ്റീവ് ചാർജ് ആണ്, ഹിയർ ഓൾസോ വി ഹാവ് എ പോസിറ്റീവ് ചാർജ്. സോ ദിസ് പോസിറ്റീവ് ചാർജ് വിൽ റിപ്പൽ ദിസ് plus 1 coulomb charge or the test charge, right? So in order to overcome that repulsion we have to do a work. So that work is known as electrostatic potential. So how we can define electrostatic potential? Is it clear how to bring that unit positive charge to point P? So that work done is stored as electrostatic potential. So we can define the electrostatic potential. So electrostatic potential at a point P in an electric field is the work done by an external force in bringing a unit positive charge from infinity to that point. So V will be equal to W by Q. We can write it as W by Q. This is the general equation for electric potential, that is V will be equal to W by Q, that is work done by charge. So W by Q is V, potential. Okay, and we can see that this is a scalar quantity, right? And the unit, what will be the unit? Work by charge, right? So work means joule per coulomb. Okay, joule per coulomb, or we can say this is volt. So this is the unit of electrostatic potential. So electric potential or electrostatic potential is the work done by an external force in bringing a unit positive charge from infinity to that point. Now we can see how we can find the potential due to a point charge. Then it will be more clear. We are going to find the potential due to a point charge. So electric potential due to a point charge we are finding means we have to consider a point charge. Okay, plus Q will be a point charge, and we have to find the electric potential due to this point charge plus Q. Okay, so here we can see the diagram. So this is plus Q charge, and here at a distance r from plus Q charge we are considering a point P. Okay, the distance between plus Q charge and P is small letter r, and we can see the direction of the electric field. So if we are taking a plus Q charge means there will be an electric field around this, right? The direction of electric field will be away from this point charge because this is positive charge, right? So the electric field direction is as shown here. Okay, that will be outwards, and here we have to find the electric potential. For that we are considering a point A here. So this point A means here we are placing a unit positive charge. So the distance between plus Q charge and A is x. അതായത് പോസിറ്റീവ് ചാർജും അതുപോലെ തന്നെ യൂണിറ്റ് പോസിറ്റീവ് ചാർജും പോയിന്റ് ചാർജും തമ്മിലുള്ള ഡിസ്റ്റൻസ് എത്രയാണ്? എക്സ് ആണ് എടുത്തിട്ടുള്ളത്. സോ ആദ്യം നമ്മൾ കൺസിഡർ ചെയ്ത പോയിന്റ് ചാർജ് ആണ് പ്ലസ് ക്യൂ. അത് പി എന്ന് പറയുന്ന പോയിന്റിൽ നിന്ന് എത്ര ഡിസ്റ്റൻസ് അകലെയാണ്? ആർ ഡിസ്റ്റൻസ് അകലെയാണ്. ഇനി നമുക്ക് കാണേണ്ടത് എന്താണ്? ഇലക്ട്രിക് പൊട്ടൻഷ്യൽ ഡ്യൂ ടു ദിസ് പോയിന്റ് ചാർജ് പ്ലസ് ക്യൂ ആണ്. സോ ഹിയർ വി ആർ കൺസിഡറിങ് എ പോയിന്റ് എ, ആൻഡ് ഹിയർ അറ്റ് എ വി ആർ പ്ലേസിങ് എ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ്. ആ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് എന്താണ്? ഒരു ടെസ്റ്റ് ചാർജ് ആണ്, റൈറ്റ്? ആൻഡ് ഹിയർ the electric potential, that means the electric field intensity at A we have to find first. So what will be the electric field intensity at A? A il undavuna electric field എത്രയായിരിക്കും? Here due to this charge alle, so E will be equal to 1/4 pi epsilon 0 Q by distance square, right? So here charge is plus Q and distance is how much? X. X is the distance between plus Q charge and A. So the equation will be 1/4 pi epsilon 0 Q by X square. So this is the electric field intensity at A. Clear? And we are placing the unit positive charge at A, and we have to move this unit positive charge from infinity to the point P. Right? For that, അതായത് നമ്മൾ ഇവിടെ കാണാൻ പറ്റും ഇലക്ട്രിക് ഫീൽഡ് ഇൻറ്റൻസി, അതായത് ഫീൽഡിൻ്റെ ഡയറക്ഷൻ എങ്ങോട്ടാണ്? റൈറ്റ് ആണ്. സോ വി ആർ മൂവിങ് ദിസ് എഗെയിൻസ്റ്റ് ദ ഫീൽഡ് ആണ്. ഓക്കെ, അതായത് ഈ ഡിസ്റ്റൻസ് എങ്ങോട്ടാണ് വരുന്നത്? ഡി എക്സ് എന്ന് പറയുന്ന ഒരു സ്മോൾ ഡിസ്റ്റൻസ് നമ്മളിവിടെ കൺസിഡർ ചെയ്തിട്ടുണ്ട്. എ എന്ന് പറയുന്ന പോയിന്റിൽ നിന്ന് ഡി എക്സ് എന്ന് പറയുന്ന ഒരു സ്മോൾ ഡിസ്റ്റൻസ് കൺസിഡർ ചെയ്തിട്ടുണ്ട്. ഇത്രയും ഡിസ്റ്റൻസ് ഒരു യൂണിറ്റ് പോസിറ്റീവ് ചാർജിന് മൂവ് ചെയ്യണം എന്നുണ്ടെങ്കിൽ അത് എങ്ങോട്ടാണ് മൂവ് ചെയ്യുന്നത്? ഇത് ഇലക്ട്രിക് ഫീൽഡിൻ്റെ ഡയറക്ഷനാണ്. അതിന് ഓപ്പോസിറ്റ് ആയിട്ടാണ് എന്ത് ചെയ്യുന്നത്? ഈ ഡിസ്റ്റൻസ് മൂവ് ചെയ്യുന്നത്, അതായത് യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് മൂവ് ചെയ്യുന്നത്. അപ്പോൾ അവിടെ ഉണ്ടാവുന്ന വർക്ക് ഡൺ എങ്ങനെയായിരിക്കും? ദാറ്റ് വിൽ ബി എഗെയിൻസ്റ്റ് ദ ഇലക്ട്രിക് ഫീൽഡ്, മീൻസ് ദാറ്റ് ഷുഡ് ബി നെഗറ്റീവ്. ഓക്കെ, അപ്പോൾ അവിടുത്തെ വർക്ക് ഡൺ ആണ് നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യേണ്ടത്. സോ എത്ര വർക്കാണ് അതായത് യൂണിറ്റ് പോസിറ്റീവ് ചാർജിനെ കൊണ്ടുവരാൻ വേണ്ടി ചെയ്യുന്നത്? സോ ഹിയർ വി ഹാവ് ടു ഫൈൻഡ് ദ വർക്ക് ഡൺ ഫോർ മൂവിങ് എ യൂണിറ്റ് പോസിറ്റീവ് ചാർജ് ത്രൂ എ ഡിസ്റ്റൻസ് ഡി എക്സ്. So that small distance we will consider here as dx, and we are going to find the work done for bringing this unit positive charge. So how we can find the work done? We know that work done W is equal to force into displacement, right? F into ds we are finding here, the distance is x, so F into dx we can do. And how we can find the force? We have the electric field. E is equal to F by Q, right? That equation we have studied. E is equal to F by Q, and here Q is plus 1 coulomb, right? If Q is equal to plus 1 coulomb, what will be electric field? Electric field will be equal to the electric force itself, right? So instead of F we can write E. So what the equation will be? W is equal to E dx, and the direction of dx is opposite to electric field, means we can write this as minus. So our work done will be equal to minus E dx. Clear? how we are getting this? Work done is always force into displacement. Work done എന്ന് പറഞ്ഞാൽ എന്താണ്? Force into displacement ആണ്. ഇവിടെ force എന്ന് പറയുന്നത് ഏത് force ആണ്? അതായത് E is equal to F by Q ആണ്. Electric force ആണ്. So that F by Q we are finding. അല്ലേ? E is equal to F by Q ആണ്. ഈ Q എന്ന് പറയുന്നത് എത്രയാണ്? +1 കൂളം ആണ്. അപ്പോൾ E എന്ന് പറയുന്നത് എന്തിന് ഈക്വൽ ആയിരിക്കും? ഫോഴ്സിന് ഈക്വൽ അല്ലേ? സോ ഇൻസ്റ്റെഡ് ഓഫ് F we can substitute E. Okay, and E is negative only because dx is moving opposite to the direction of electric field. So W will be equal to minus E dx. So how we can write? If the unit positive charge is moved through dx, the work done dW will be equal to minus E dx. So this concept you should understand. Please don't by heart this. Okay, so if you are understanding this concept, it will be very easy. So here we are calculating the work done and we know the electric field. So it is very easy to find the work done by using the equation minus E dx. Okay, so dW only we are finding here. That means only small work done we are finding here. Then the total work done we have to find. How we can find the total work? Then we can integrate. So integral infinity to R we have to do. Then we will get the total work done. That will be stored as the electric potential. Right. Is it clear, the concept? Okay, so now we can move to the derivation of that. So here we are finding work, means work done we will find, and then what will be the total potential. So V is the equation for finding the electric potential, right? V will be equal to minus integral infinity to R E dx we can write here. Minus integral infinity to R E dx. So the same equation we are writing because the work done will be replaced by electric potential, right? So V will be equal to minus integral infinity to R E dx. And ഈ ചെയ്യുന്ന വർക്ക് ആയിരിക്കും എന്താ പൊട്ടൻഷ്യൽ ആയിട്ട് ഇലക്ട്രിക് പൊട്ടൻഷ്യൽ ആയിട്ട് സ്റ്റോർ ചെയ്യുന്നത്. അപ്പോൾ അതുകൊണ്ടാണ് നമ്മൾ ഡബ്ല്യുവിന് പകരം ഇവിടെ എന്താ എഴുതിയത്? വി എന്ന് എഴുതിയത്. ക്ലിയർ? ഇനി നമുക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. വളരെ ഈസിയാണ് എനിക്ക് ചെയ്യാൻ വേണ്ടിയിട്ട്. എന്ത് ചെയ്താൽ മതി? ഹിയർ വി ക്യാൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ദ ഇക്വേഷൻ ഫോർ E, electric field in the equation substitute ചെയ്യാം. What will be the equation? V is equal to minus integral infinity to R 1 by 4 pi epsilon 0 Q by x square, that we have already found, right, into dx. So here we have to integrate within the limit infinity to R. Now what are the constants coming here? Constants ne onnu puratthekku edukam. Then V will be equal to എങ്ങനെ എഴുതാം? minus Q by 4 pi epsilon 0. Here Q is constant, then this is also a constant, right? So minus Q by 4 pi epsilon 0 integral infinity to R x raised to minus 2 dx. So only x raised to minus 2 we have to integrate. And how we can write this x raised to minus 2? The same thing we can write again, that is V is equal to minus Q by 4 pi epsilon 0. Here no need to make any changes. Here only we have to do, because x raised to minus 2 means, how we can integrate that? X raised to minus 2 plus 1 divided by minus 2 plus 1 will come, right? This is the integral of x raised to minus 2. So what will be that? Minus 1 by x, that will be equal to minus 1 by x. How we can write now? Here there was minus Q and minus 1 by x, right? So that will get cancelled. Then this will be plus Q by 4 pi epsilon 0. Clear? So both will get cancelled. Then Q by 4 pi epsilon 0 1 by x within the limit infinity to R. Limit എത്രയാണ്? Infinity to R ആണ് ചെയ്യേണ്ടത്. Now we can apply the limits. So how we will apply the limits? Upper limit minus lower limit we have to do, which is upper limit R and lower limit is infinity. അപ്പോൾ upper limit minus lower limit ആണ് ചെയ്യേണ്ടത്. upper limit ഇവിടെ R ആണ്, then infinity is the lower limit. This Q by 4 pi epsilon 0 we can write in the similar way. അതുപോലെ തന്നെ എഴുതാം. Then limit only we have to apply here. Then what we will get? 1 by R minus 1 by infinity, that is upper limit minus lower limit. Then here what is the value of 1 by infinity? 1 by infinity എത്രയാണ്? That is 0, right? So how we can write? 1 by infinity 0 ആണ്. So our equation will be V is equal to Q by 4 pi epsilon 0 into 1 by R. Or we can write it as V is equal to 1 by 4 pi epsilon 0 into Q by R. Okay, so this is the equation for finding the potential due to a point charge. So please don't by heart the equations. You can just understand it and study, then it will be very easy to derive the equation. Only the final equation you have to remember. All the other things you can derive. Okay, so hope it is clear to you. Now we can move to the next topic, that is potential due to an electric dipole. now we can find the equation for finding the potential due to an electric dipole. So due to electric dipole, we have already discussed that equation for getting the electric field. In the last chapter we have already done, right? So what is electric dipole? Electric dipole is a system of charges. They are separate, equal and opposite charges. They are separated by a small distance, right? Now here we will find the potential due to electric dipole. So in the last case we have already discussed that electric field due to electric dipole. So there were two derivations. Clear? That means along the axial line and along the equatorial line we have derived, because that was a vector quantity, so the direction was also important. But in this case we have to derive only one equation for electric dipole, and in the last equation we will give that that cases that we will apply here. That means for the last equation, when we are giving the different values for the angle only, we have to get the axial line and equatorial line. Here no need of both derivations, because axial line and equatorial line separately we don't have to find. Only this one equation that we will derive, that is equation for potential due to an electric dipole, and we will apply the conditions in the last equation. Okay, then we will easily get the equation for axial line and equatorial line. So this is very easy to do, but the derivation is very important, that you have to understand and study. Okay, please don't by heart this. The diagram we have to draw, and then we have to just understand the concept, and then we can substitute the equations. That is very easy to do now. Okay, now here we are considering an electric dipole. Electric dipole means this plus minus q charge is here and plus q charge is kept here. They are separated by a distance 2a. So this is the center. O is the center of the dipole, and here we can see this OA is A and OB is also A. And here we are considering a point P at an arbitrary point, that is P. Here we are considering a point P, and we have to find the electric potential due to this electric dipole at P. ഇവിടെ നമ്മൾ കൺസിഡർ ചെയ്യുന്ന ഡൈപ്പോൾ ഏതാണ്? മൈനസ് ക്യൂ ആൻഡ് പ്ലസ് ക്യൂ ചാർജസ് ആണ്. ദേ ആർ സെപ്പറേറ്റഡ് ബൈ 2a എന്ന് പറയുന്ന ഡിസ്റ്റൻസിലാണ് ഉള്ളത്. അവയ്ക്കിടയിലുള്ള ഡിസ്റ്റൻസ് സെൻറ്റർ O ആണ്. ഓയിൽ നിന്ന് എയിലേക്കുള്ള ഡിസ്റ്റൻസ് a ആണ്. സോ OB ഈസ് ഓൾസോ a. ഇനി നമ്മൾ എടുക്കുന്ന ഏതാണ്? അറ്റ് എ ഡിസ്റ്റൻസ് r ഫ്രം ദ സെൻറ്റർ ഓഫ് ദ ഡൈപ്പോൾ വി ആർ കൺസിഡറിങ് എ പോയിന്റ് P. അതായത് r എന്ന് പറയുന്ന സ്മോൾ ലെറ്റർ r ഈസ് ദ ഡിസ്റ്റൻസ് ഫ്രം O to P. OP എന്ന് പറയുന്ന എത്രയാണ്? സ്മോൾ ലെറ്റർ r ആണ്. സോ ഇൻ ദിസ് പോയിന്റ്, അതായത് പോയിന്റ് പിയിൽ ഉണ്ടാവുന്ന ഇലക്ട്രിക് പൊട്ടൻഷ്യലാണ് കാൽക്കുലേറ്റ് ചെയ്യേണ്ടത്. ഹിയർ വി ക്യാൻ സി AP is equal to R1 and BP is equal to R2. These two we are just taking. Okay, അതായത് നമ്മൾ R1 R2 എന്ന് പറയുന്നത് എന്താണ്? ഇവിടുത്തെ ഫിക്സഡ് ക്വാണ്ടിറ്റീസ് അല്ല. വി ആർ ജസ്റ്റ് ഗിവിംഗ് ദ നെയിംസ് ടു അണ്ടർസ്റ്റാൻഡ് ദാറ്റ്. ഓക്കെ, സോ ഇൻ ദ ഫൈനൽ ഇക്വേഷൻ ദർ ഷുഡ് നോട്ട് ബി R1 and R2. For that we have to give substitutions. അതായത് R1 R2 വരികയാണെന്നുണ്ടെങ്കിൽ എന്ത് ചെയ്യണം? അതിനെ നമ്മൾ ചേഞ്ച് ചെയ്യണം, ബിക്കോസ് ദാറ്റ് വി ആർ സെലക്ടിങ് R1 and R2 എന്ന് പറയുന്നത് നമ്മൾ സെലക്ട് ചെയ്യുന്ന രണ്ട് വാല്യൂസ് ആണ്, രണ്ട് ഇക്വേഷൻസ് ആണ്. ഓക്കെ, so that we have to change in the final equation. So here we have to understand that this OA is A and OB is A, and here only this much is there in our diagram. Okay, here AP we can join and BP, that is the distance from A to P, and this is the distance from B to P. And now we can find the potential at P due to minus Q charge. And here we can see the rest of the things that I will explain. First of all, we just consider this only this thing, and this R1, then R2, and the center to R. Okay, that is OP is R. No need to worry about these two perpendiculars that I will discuss. Okay, now we can see here the potential at P due to minus Q charge we have to find, and then the potential at P due to plus Q charge we have to find. What is the equation for finding potential due to minus Q? Minus Q means 1 by 4 pi epsilon 0 minus Q by distance, right? So by R1, that is the equation for finding the potential at P due to minus Q charge. ഇനി അതായത് മൈനസ് ക്യൂ ചാർജ് കൊണ്ടുണ്ടാവുന്ന പൊട്ടൻഷ്യലാണ് എന്ത്? V1 എന്ന് പറയുന്നത്. ദാറ്റ് ഈസ് ഈക്വൽ ടു 1 by 4 pi epsilon 0 minus Q by R1 ആണ്. ദെൻ ഇൻ ദ നെക്സ്റ്റ് കേസ് വാട്ട് വി ഹാവ് ടു ഡു? വി ഹാവ് ടു ഫൈൻഡ് ദ പൊട്ടൻഷ്യൽ അറ്റ് P ഡ്യൂ ടു പ്ലസ് ക്യൂ ചാർജ്. അതായത് പ്ലസ് ക്യൂ ചാർജ് കൊണ്ട് ഉണ്ടാവുന്ന പൊട്ടൻഷ്യൽ നമ്മൾ V2 എന്നാണ് എടുത്തിട്ടുള്ളത്. ദാറ്റ് ഈസ് ഈക്വൽ ടു 1 by 4 pi epsilon 0 Q by R2. So these are the two equations. Now how we can find the total potential at P? In the two equations add it. So V will be equal to V1 plus V2 in the very easy to add. How we can add? 1 by 4 pi epsilon 0 minus Q by R1 plus 1 by 4 pi epsilon 0 plus Q by R2. Now what are the quantities coming as constant? Constants are Q by 4 pi epsilon 0. That will be taken outside the bracket, that is Q by 4 pi epsilon 0. And now the remaining equation is minus 1 by R1. Yes, plus 1 by R2. So minus 1 by R1 plus 1 by R2 is coming within bracket. Clear? Now we have to simplify the equation. V is equal to Q by 4 pi epsilon 0 into minus 1 by R1 plus 1 by R2. So how we can write? We can take the LCM, right? Then what we will get? Q by 4 pi epsilon 0 minus R2 plus R1 by R1 R2. Right. Then how we can write this? This R1 minus R2 by R1 R2 we can write. Right. So V will be equal to Q by 4 pi epsilon 0 R1 minus R2 divided by R1 R2. So this is the final equation actually for potential due to an electric dipole. But there is a problem, right? So this is R1 and R2 is not specified. That values we have to find. What is R1 and what is R2? Here R1 is the distance between A plus Q charge, minus Q charge and point P, and R2 is the distance between plus Q charge and P. Right. So that values we have to find, or that equation for R1 and R2 we have to find. Then for that, here we can consider the diagram. See the distances. Here we can see this R1 and this R2. They are not same, right? The length is not the same, and this is not equal to R also. So one thing we can do is, here we can draw a perpendicular, that is BN. Here that BN we can draw, which is perpendicular to PO. That means we can draw a normal to PO, that is BN is the normal here. BN perpendicular to PO. In the same way, here we can extend this, that is we can draw, yes, one more perpendicular, that is AM perpendicular to PO, that is produced here. Okay, so that PO is over here, and we can draw this perpendicular AM. Now is this clear? Because these two triangles we are making here, that is this one AM is the perpendicular drawn to PO, or okay PO, and here this BN is the perpendicular drawn to PO again. Now we can see that here the angle is theta, and here also the angle is theta. Now we can find the equations for ON and OM. Here OM is here and ON is here, right? Why it is like this is, here we can, then R is here, then R plus this OM we can calculate, right? Then that will be almost similar to R1, right? Here R1 is AP, and this R1 is almost similar to this PM. Clear? So PM will be equal to OP plus OM, right? Then if we find this OM, we can find R1. In the similar way, here also we can find, right? So here these two are not same. R and R2 are not same. So if you draw the perpendicular here, what happens is, here we can find ON. ON we can find as A cos theta. That means from the triangle we have to take cos theta. Okay, then ON will be A cos theta. Now we have to find this R2, that is PB, right? And PB is equivalent to NP. Here we can see that. So if we find NP, that will be equal to R2, right? So how we can find NP? Now we have ON and this OP also. So OP is the total distance R. So OP minus ON will be NP, right? So in such a way we can find NP. So what will be NP? Here OP is R. So R minus ON, that is A cos theta. So that will be R minus A cos theta. Here we will get the equation for R2 as R minus A cos theta, and in the same way here OM is also equal to A cos theta, right? So here what happens is that in case of AP is equal to MP, right? So how we can find MP here? R plus A cos theta, right? Because OP is R plus A cos theta plus OM, that will be equal to R plus A cos theta. So we can see that this R1 is equal to R plus A cos theta and R2 is equal to R minus A cos theta. So for exam, if you are writing this, that OM and ON, directly we can write the equations, that is OM is equal to ON is equal to A cos theta. Okay, and now need to write all the steps for that, but I will discuss that only because you should get an idea about that, how it is coming. That is why I am saying that, and then you can substitute the equations of R1 and R2. Okay, so R1 will be equal to R plus A cos theta and R2 will be equal to R minus A cos theta. Okay, അപ്പോൾ ഞാൻ ജസ്റ്റ് സ്റ്റെപ്സ് ഡിസ്കസ് ചെയ്യുന്നുണ്ട്, അപ്പോൾ അത് നിങ്ങൾക്ക് എക്സാമിന് ആ സ്റ്റെപ്സ് സ്കിപ്പ് ചെയ്യാം, ബട്ട് യു ഷുഡ് അണ്ടർസ്റ്റാൻഡ് ദാറ്റ്. അതുകൊണ്ട് അതൊന്ന് കണ്ടതിന് ശേഷം നിങ്ങൾക്ക് എക്സാമിന് എഴുതുമ്പോൾ ഇത് ഡയറക്റ്റ് ആയിട്ട് എഴുതാൻ പറ്റും. ഓക്കെ, ദെൻ സബ്സ്റ്റിറ്റ്യൂട്ട് ദ വാല്യൂസ് ഓഫ് R1 and R2, ദെൻ വി വിൽ ഗെറ്റ് ദ ഇക്വേഷൻ ഫോർ പൊട്ടൻഷ്യൽ ഡ്യൂ ടു ആൻ ഇലക്ട്രിക് ഡൈപോൾ. ദാറ്റ് ഈസ് VN and AM we can draw here, and we are taking the triangles here. This one, first of all we can consider this triangle BON, clear? BON, and here angle is theta here, and this is 90 degree, right? Here we draw the normal, right? ON is the adjacent side, so if you take cos theta, what will be the equation from triangle BON? If you are taking the cos theta, so what we will get? Cos theta is adjacent side, this is ON divided by OB, right? So we can write cos theta is equal to ON by OB. From triangle BON, we can write cos theta is equal to ON by OB. In a similar way, we have to, then we can write the equation of ON, right? What is OB here? OB, this is A, this length is A, right? So ON is equal to OB cos theta, then that will be equal to A cos theta, because for OB we can write A. So ON will be equal to A cos theta. Clear? So this is our next equation. Now OM also we want to find. So how we can find OM? Again consider the triangle. Yes, AOM. AOM. Then what will be the equation? Cos theta. Here which one we want to find? This OM we have to find, right? So how we can find OM? Taking cos theta. Then what will be the equation? Cos theta is equal to, yes, OM divided by this OA, right? OA is equal to A, then what will come? Triangle OAM or AOM. Cos theta is equal to OM divided by OA, then OM will be equal to OA cos theta. Clear? So OM can be written as A cos theta because OA is equal to A. Now we are getting the two equations ON and OM. Now we can substitute. Now we can take the approximation. Here we have told that AP is approximately equal to PM, right? AP, that is AP is approximately equal to PM. Therefore we can write this AP is equal to, how we can write? PM is, this is approximately equal to OP plus OM, right? Or PO plus OM. So how we can write? R1 is equal to this R1. This one we are finding, right? So R1 will be equal to this R plus OM is A cos theta. So R1 is equal to R plus A cos theta. And here we can say, see that BP is approximately equal to PN, right? This is also same. So how we can write? Yes, R2 will be equal to, how we can write this? R2, this is equal to this OP minus ON, right? That means R minus A cos theta. This is A cos theta. So R2 will be equal to R minus A cos theta. Now we can substitute the values in the equation. V is equal to Q by 4 pi epsilon 0 R1 minus R2 divided by R1 R2, right? That we have already found. No. So there we can substitute. What we are getting? Substitute. Then V will be equal to Q by 4 pi epsilon 0, and then R1 minus R2. So R will be R plus A cos theta minus R minus A cos theta. So this minus we are taking inside. So R plus A cos theta divided by R1 into R2, that is R plus A cos theta into R minus A cos theta, that is A plus B into A minus B. That will be equal to A square minus B square. So R square minus A square cos square theta. Now we can simplify this. Here this R and R will get cancelled. Then what is remaining here? Here we can see V is equal to Q by 4 pi epsilon 2A cos theta divided by R square minus A square cos theta. And again we can give one more substitution here. Here this 2AQ we can see. What is 2AQ? That is P, dipole moment, right? So instead of 2AQ we can give P. So the equation will be V is equal to 1 by 4 pi epsilon 0 P cos theta divided by R square minus A square cos square theta. So this is the final equation for finding the electric potential due to an electric dipole. That is V is equal to 1 by 4 pi epsilon 0 P cos theta divided by R square minus A square cos square theta. If you have any doubts, you can just rewind this and you can understand the concept. Now we can just see that what will be the equation for the axial line and equatorial line. So here we can consider this point P along the axial line. So what will be the angle theta here? Here if you are taking the point P over here, we are getting angle theta here. Right, suppose this is taken along the axial line of the dipole, means this will be extending like this. So what will be the angle? Angle will be 0. Right, theta will be equal to 0. So that means this point P will be coming here somewhere. Right, so the angle will be 0. Then what will happen to our potential? Yes, electric potential V is equal to 1 by 4 pi epsilon 0 P cos theta by R square minus A square cos square theta. So here we can substitute the value of theta. So here theta is equal to 0 degree. So what will come? Cos 0 is 1. So that we can see that V will be equal to 1 by 4 pi epsilon 0 P into cos 0, that is 1, P into 1, P divided by R square minus A square into 1. So P by R square minus A square. This is the equation along the axial line of a dipole in the case of the potential along the axial line of the dipole. So here we can see if we are taking this A very less than R, then what will happen? That means the length of the dipole is very much less than R, then this A square can be neglected. So what will be the equation? V is equal to 1 by 4 pi epsilon 0 P by R square. And we can see that this electric potential varies inversely as the square of the distance. Right. So V is proportional to 1 by R square. And is this clear? That is in the case of axial line. And suppose this is taken along equatorial line. So if point P is at this point, so what happens here? The angle will be 90 degree, right? So in the case of equatorial line, cos 90 is coming. So what will happen to our equation? Yes, V will be equal to cos 90 0, right? So P into cos 90 means P into 0. So all the term will be 0. That means there will be no electric potential along the equatorial line of the electric dipole. Clear? So this is all about the electric potential due to an electric dipole.